Before we get too heavily involved in doing calibration on this scope, one thing I have noticed is if you have a look at the backup battery, it's down to 1.6 volts. Now the scope isn't flagging up anything about this battery being low, but it must be getting close to the point where it will actually record that. Now we know we got an error message on the front screen. I'm not exactly sure what that is. It's something to do with the non-volatile memory or the checksum error. That's what, according to the manual anyway. Now I don't know if we've lost our settings already and it's like totally out of calibration, or it's you know, just something wrong with the scope and it's just flagging up a sort of erroneous error. I need to change this battery, and I've got another battery, and this is the equivalent battery, and it's pretty hard to see here, but this battery is actually quite a little bit smaller than the existing battery that came on the scope board. The other thing apparently is, what you don't really want to do is disconnect the battery for any length of time, because you lose, if there are any settings in there that are sort of valid, you will lose them. Probably not a bad idea, because I think it probably needs a total recalibration there anyway. So I'm sort of in two minds about just disconnecting the battery, and it will allow the RAM to totally sort of discharge and clear, and then we can start from scratch with this new battery. Or I can put it on a sort of like a life support sort of thing by feeding an external supply in, and then going from there, hopefully just to you know, patching up the software that's in there already, correcting for calibration thing. But I don't think I'm going to do that. I think what I've decided I'm going to do is I'm going to unsolder the battery, remove the battery altogether, let the thing discharge, let the RAM forget all its settings, and then we'll start from scratch with a full fresh calibration. Now I don't know what the calibration involves. From what I've heard, it's much more complicated than the calibration I did on the Tektronix 2440. Now I don't know if they're talking about just the basic calibration on the 2440, which is like the auto calibration, but there is a more in-depth version on the 2440 that was actually quite complicated, actually, and needed quite a lot of test gear. So I'm still sort of in two minds of what to do. I'm thinking if it's sort of settings are basically right, which they look like they are. That, you know, I checked sort of inputs onto all the 4 channels. They look like the levels are all about the same. So I'm thinking, well, maybe the calibration is 99% correct, and there's just one checksum error. So what to do? I'm not sure. Maybe we'll try it with a backup supply, just to keep the thing powered as long as we can. Now the supply is available. It should be past these 2 diodes here. There's 1.5 volts, so you should be just over 1.5 volts here. Yeah, 1.6. So there's your voltage drop across the diode. According to that, actually, we're not even getting a voltage drop across the diode, which is a bit odd. So it could be that the battery is so flat. Yeah, we must be getting close to the point where it don't actually conduct on the diode. So let's pull this board out and have a look. Be a bit careful pulling these connectors off. Difficult to get hold of these. Let's get the bottom board out. Get the bottom connectors off first. So this board does all the sort of like the logic side of the scope. Connectors at the side as well. Not the easiest bloody scope to work on. I'm afraid there's a lot of noise from next door. I've got some friends round, and it's that time when the children go to bed, and these children don't like going to bed, so we'll probably have the whole street will have to hear about it in a minute. Don't you just love children? Right. Pull this out. Okay. So we've got to get this other connector out here. nothing to grip hold of on these connectors. So just leaves this capped on type flexi here, that's probably for the switches at the side. Another screwdriver somewhere. No. So, why is this board not coming out? That was easier than I thought. Okay, so we need to change the battery here, which is the little lithium battery. And it basically involves disconnecting a couple of wires on the back. They're probably plated through, so they're probably going to be a bit fiddly to remove. Now I'm wondering how long I've got before I need to apply power to it. So this is our power supply. It's currently limited at about sort of 50 milliamps, just in case anything shorts. Just check our supply voltage. That's that'll do. So what we'll do then is we'll connect that to there, and that to the positive. And that should keep us backed up for the time being. So the idea is to get this battery out as quickly as possible. It doesn't matter too much because we're backed up. And get the new one in. So bear with me. Okay, I think those two connections there are just supports more than anything else. This is the battery itself. Quite a thick plated thermal plane here, so okay, there's the battery out. So it's used to be running on sort of like life support from the external supply, so that's the battery out. You can see that actually the battery is actually mounted in an internal case. That's interesting. Just pop that battery out of there. No, it's well and truly stuck in there, but if you can see, oops, I just shortened that battery out, but it hasn't helped it a lot. It's basically the same battery inside. You can see the two exactly the same. So let's clear the holes. Use a desoldering brace, probably best thing. Carefully not to short out the two connections, as long as we've got backup supply on. Let's get you up a bit higher so you can see what's going on with the board. Just clearing the two holes. And we've got a diode in the way here, so the voltage shouldn't be backfeeding into the into the battery, so we should be safe. We've got a diode here, and the positive's on the cathode, so it's no current flowing back this way. Just clear those holes. That's nicely cleared. Clear these two. These are just, as I say, just mounting points for the battery. Okay, let's just pop the new battery in. Like that. What you're supposed to do is crop the leads before you solder. Certainly what we're taught at work. You don't solder a connection and then crop it. Now what we must be careful here is not to short out, because it's a new battery. I don't want to put a short on the new battery. These batteries aren't that cheap either. And they're quite hard to get hold of actually. I found a couple on eBay, but they were like 15-16 quid. I managed to get this one from Farnell. It took a couple of days to come, so they're obviously not that popular, or not that common, should I say. For interest, apparently the later version of this scope uses a different backup system. It uses the old Dallas type, but this is the earlier version. It's using one of these Keeper lithium batteries, and it's a 750 milliamp hour. It's an LTC 7P, I think, to be replaced with the PN version, which is what this one is. So sort of a bit odd really working on the board like this, because you're aware that it's not actually fully off. It's still sort of it's powered by this backup battery. And it's obviously keeping all the memory sort of alive, so you're working basically on a live board. I mean, you know, it's only a few microamps running through it probably, but it's still a bit of a challenge to get it to a. Well, we'll zoom out a bit so you can see what's going on. Alright, so I'm just trying to get the solder to flow on these joints. So they're the two connections that don't actually do anything, and these are the ones that do. So just turn the board over. Okay, I'll come back off, take the support away. That's the battery in position. Check and make sure it's not poking through too far. Looking good. So let's get it back together and see what happens.